Hi, I'm Lavanya, and this is my friend Paige. Today, we're going to talk about particle accelerators. First, we'll need to understand the motion of particles in electric and magnetic fields. We'll use a positively charged particle to illustrate. Paige will model this. Electric fields occur when there are differences in the electrical potential between two areas. Under their influence, positive particles accelerate towards lower potentials. This is similar to how a ball rolls down a ramp spontaneously. Initially, both objects have a lot of potential energy. This is converted into kinetic energy as they move through their respective fields, which we can see by their greater speed. Now, if we wanted to use electric fields alone to noticeably accelerate particles, we need fields as long as football fields. Not super practical. Let's bring in some ideas from magnetism to build on this. Here, dots represent magnetic field lines coming out of the screen. Magnetic fields are similar to electric fields, but magnetic forces are quite unique. They depend on the velocity of a moving charge, and they always act perpendicular to both the magnetic field and the velocity's direction. Forces of this manner are called centripetal, and they cause movement in a circle. We can do some derivations with this fact to show that the radius of this circle depends on its velocity, so faster particles move in bigger circles. Now, let's put this together. Inside of a cyclotron, particles experience both electric and magnetic fields, but only one at a time. First, a particle is accelerated through a small electric field. Like the ball rolling down a ramp, this gives it some kinetic energy and boosts its velocity. When the particle, now with some speed, enters a magnetic field, it starts to move in a circle. Just halfway through its rotation, however, it goes through the same electric field, but now in the reverse direction. This gives it an extra boost of energy again. This means it moves a bit faster when it re-enters the magnetic field, so it'll move in a slightly larger half circle until this happens again. Particles are repeatedly accelerated through electric fields with constantly reversing directions and circled back through a magnetic field. In the real world, particles can make thousands of revolutions in a fraction of a second. Eventually, the small boost of energy from each revolution will add up to allow the particle to move at the desired speeds, which is when they leave the cyclotron. Now, cyclotrons were made as early as the 1920s. Modern particle accelerators use the same principles we learn today in even more powerful combinations to create devices that can speed up particles to speeds comparable to that of light. That's pretty cool, since light is the fastest thing we know of. Accelerators have applications in everything from experimental physics research to modern medicine. It's awesome the things understanding physics allows us to do. Thanks for watching the video. Here are my references.